Hey guys, so we have finals coming up. And so for our stats final, I wanted to show you, give you a general overview of what I think would be great things to study, prepare um, for the upcoming final. So there's going to be definitions. I know the first couple chapters, they're filled with definitions. We talk about different sampling methods, what's a population versus this sample, some different types of data, interval, ratio, ordinal, descriptive, and inferential statistics. So it's kind of jam-packed with definitions. So please make sure you look over your definitions from the chapters. And then empirical rule is that kind of general guideline of when you're looking at a bell-shaped curve, that you understand that at plus or minus 1 standard deviation, you get 68% of your population. Plus or minus 2 is 95, plus or minus 3. We could verify that by looking at the normal calculator at 68%. If I went plus or minus 2 standard deviations, I'd be at 95%. So it's that general rule of 68, 95, 99.7%. Also, we're looking at some basic probability rules. So when we are combining things, if we're picking one thing and we're looking at mutually exclusive, or if they overlap, what the equations are for those. Most of the probability stuff is by hand. So you have to have some basic formulas that you may need for independent events. If we're picking two things, the probability of that happening. So on your final exam, I am going to allow you to bring a cheat sheet. You can have one page, normal page, 8.5 by 11 inches. And on one side, you can print whatever you want. Make sure it's your handwriting. I don't want copies of things shrunk down. So one page of whatever you want. But that's for the final exam. Expected values, and so there was like insurance type problems or game type events. What's the probability that the expected value of a game that someone would play? You can do those type problems in StatCrunch. If you do a custom calculator, you could put your values in there, weights in it. Here, let's do a quickie. So if I play a game, I either win $25 or I lose $10. The probability that I win is probably low, so let's say like 20%, and then the probability that I lose is 80%. So again, these totals have to add up to 100%. But if I want to find out what's my expected value, if I go to that custom calculator, my values of my winnings are in var 4, my weights are in var 5, and bam, my mean that I get is -3. So I'm expected to lose $3 every time I play. The standard deviation of 14. So again, I could be up for a while, but in the long run, I should expect to be down by $3. What else do we have? Binomial distributions. And again, there's some great formulas in the text, but I am a fan of the binomial calculator. I've showed that in the videos. And so like with basketball, let's say that I shoot 10 free throws. I'm a excellent basketball player. And so I'll say I'm an 80% free throw shooter. This will tell me, what's the probability that I make 5 or less. So this way is 3%. What's the probability that I make exactly 8? Probably would be my highest probability is 30%, right? That's the highest column there. If I wanted to do between, I make in between 6 and 9, right? And so it's more understanding what are we finding. Like there's an 85% chance, if I am really an 80% free throw shooter, shooting 10 shots, that I have an 86% chance to make between 6 and 9, and including 6 and 9. Normal distribution, same thing. I'm going to go to my StatCrunch that you do have access to. You are allowed to use a computer. And so when I look at my normal distribution, again, versus like that standard normal, with the mean 0 and standard deviation of 1, if we were looking at someone with the mean of an IQ score is 100, standard deviation is about 15. And so if I want to say, what percentage of people that take the IQ test score above 115? So I said above 115, which this gives me the below. So again, I love the great pictures. So above 115 is about 16% of the people score above 115. Again, I can get crazy with the numbers. I don't have to do exactly one standard deviation above or below, which makes this process awesome. And it's a great visual calculator. Again, it does the between or it does just normal. Standard error of the mean, so that's using your normal calculator. So your mean for sample means is your mean. The means for your p-hat, your sample proportion, is your population proportion. So what we have to remember when we're doing these is that we have to manipulate that standard deviation. So if I go back to here and say that I'm looking with IQs of people, a lot of times people forget if I'm sampling 25 people and I'm looking at their mean IQ score, I have to change my standard deviation. The more people I have, the less distribution I'm going to have. So if I sampled 25 people, I would have to divide my population standard deviation divided by the square root of my sample size. So on this particular problem, if I had a sample size of 25, I would have to divide it by the square root of 25. So I'd be dividing it by 5, which it doesn't do this on StatCrunch. I'm going to have to punch this in on a calculator. So make sure you bring some basic calculator. But my standard deviation would now be 3. And so this shows, like, if I sampled 25 people and their average IQ was above 118, like something strange is going on, right? Like we have an alien sample because they're super smarter than us, because it's very unlikely, times 10 to the negative 10th, that would happen. This would be an unusual group of 25. And again, that's where we get to start making inferences of the people that we sample, or maybe as a population, our IQ is increasing. It is not. It's probably decreasing. Hopefully it's increasing. We're in school to increase our IQ, but the general population, I feel like it's going lower. If it's proportions, same thing. Your population proportion or belief proportion may go here, 60% approval rating of Bob, whoever Bob is. And then your standard deviation, you would just need to make sure that you use that formula, the square root of p times 1 minus p over your sample size. So make sure you're using the correct thing. Confidence intervals and sample sizes, again, using StatCrunch. If we're doing sample means, we're looking at t-stats. One sample is what we're typically looking at. And whether we have the data like a long list in one of these columns or we just have a summary of the data. So I could put in, we had a mean of 8, a sample standard deviation of 1.5, and a sample size of 38. And if I want to find a 95% confidence interval, I just hit compute. And so that means that I'm 95% confident that the true population mean is somewhere between 7.5 and 8.5. So pretty nice to use. Same thing with proportions, except you do proportion stats. One sample, again, whether you have data or a summary, put your information in and click on the correct confidence interval. So y'all have done problems with that. If you want to know a sample size with these, so let's say I was looking at a mean, one sample. So I want to figure out how many people should I sample. So I'd go to width and sample size. The common mistake made here is that you put your confidence in, you put in a standard deviation that would have to be provided for you. If the margin of error was like plus or minus 4 points, the width would be 8, right? Because it's 4 to the left, 4 to the right, if it was something like plus or minus 4 points. And so this will just spit out our sample size that we need to attain, which doesn't look like a whole lot. Sample size of 3, that would be super weak. But my width went way small. Let's say a standard deviation is something different than that, like 5. That's better. So it says I need 9 people, which still isn't a huge sample size. Same thing with proportions. If I go to proportion stats, one sample, width, if I'm looking at plus or minus 3%, a lot of time in polls will always have that little tag in there. That width for plus or minus 3% would be 0.06. Let's say it's believed to be about 60%. I want to be 95% confident that I'm capturing the true population proportion. I need to talk to, oh, too many decimals. I need to talk to 1,000 people, right? So you have to talk to a lot of people with proportions to get a small margin of error. So talked about that. Interpreting graphs. So if you're given a graph, make sure that you understand how to read it, whether it's a box plot, a bar chart, a pie graph. Just be aware. Correlation, line of best fit, linear regressions. So with those, we need to make sure that if we're given some data, so I'm just going to plug in some really boring data. 8, 12, 15, 16, and 20. So if I have some data, if I do a regression on it, and we've talked about simple linear regression, I could say that the x variable is my var 8, my y variable is var 9. You may have to input some data and just not transfer it over to StatCrunch. If I hit compute, like it's going to give me a picture of the graph, so I see the line of best fit. Also gives me my correlation coefficient, the 0.985. Gives me my r squared, the coefficient of determination. It gives me my equation. So here's my slope, 2.8 times x plus the 5.8. So my slope is 2.8 and then my y-intercept is 5.8. So understanding what you're doing here, does that correlation coefficient say that I have a good one? 0.985 is pretty strong. If not, we would compare it to a table. Lastly, what we have on here is our hypothesis test, and so that's what you've been dealing with most recently. And so with those, again, we're looking at t-stats or proportion stats. We're just typing in our information. So if we're doing a 2 sample, we're comparing 2 means. So McDonald's has a 20-second drive-through time with a standard deviation of 5 seconds, and we looked at 40 cars. Burger King has a 25-second mean wait time, standard deviation of 3, and we sampled 37 cars. So if I'm doing a 2 sample, I'm comparing to see if these are different from each other. And so I just want to see if they're different. So the difference is equal to 0, because if the difference is 0, that means they're the same. And so I'm just checking my alternative to see if they're different from each other. I hit compute. It tells me that I have a low p-value. So if the p is low, reject the Hogue. And so that means that I do not think that they're equal to each other, and I think that they are different from each other. So that's something you should feel comfortable doing with the hypothesis testing. So you'll be given a scenario and some information. So a quick review of what's expected on your final exam. I will send you this sheet. Again, you are allowed to have a formula sheet. If you have any questions about StatCrunch or anything like that, please let me know. Y'all have a great day and do well on your finals.